How are you, my friends? This is lecture 34 of the Algebra Course lectures, Quadratic Functions, where we graph this quadratic function and it becomes a parabola. Now, here are the objectives. You can read it. We have to find the vertex. We have to put the general form in standard, graph it, find the minimum, the maximum, the axis of symmetry also. Now, the aim of this lecture is, we have here 8 quadratic functions we can see on this slide. See, the first 4 here, not easy to graph because they are in general form. Look at here, this one, this one, this one, this one. This one easy to graph because it is in standard, something squared plus or minus a number. So we can make the shifting easy. So the whole aim here in this lecture is to go from this general, go to standard. Then we can graph it, we can find x-intercept, y-intercept, domain, range, easily, everything. Now, what is a quadratic function? Quadratic function is a function of this form. F of x is equal ax squared plus bx plus c. So we call this general form. A, B, C are real numbers. The graph, we call it parabola. It's like some kind of a U shape. Again, I will stress the idea. This is a general. F of x is equal ax squared plus bx plus c, usually given. And this is the standard form. F of x, the same function. A is the same A. X minus h squared plus k. So by using A, B, and C, I can find h and k, which I call it vertex. H and k. H, always the formula minus b over 2a, that's h. And then k will be the image of that number. So if this is like, say, 3, you say here f of 3. If this is minus half, f of minus half. This is h and this is k. Let's start with an example directly, important example. Write this quadratic function, minus 3x squared, minus 30x, minus 63 in standard form. Graph it and see where the graph is above the x. See, this is a general. So that's A, that's B, that's C, ready. Directly we can say we need h. H minus B, C minus 30 over 2A. A is minus 3. It happened here that A, B, and C are negative. They can be positive or negative. So when you simplify this, you get minus 5. Because this minus becomes plus 6, 30 over 6 is minus 5. So K is f of h. So I take minus 5 and replace it in this function here. So minus 3, minus 5 squared, minus 30, minus 5, minus 63. When you simplify all this, you get 12. So I take minus 5 and 12, that is the vertex. So I go to the standard, you know the formula, you should remember it. A, that's A minus 3, always the same A. H is minus 5, so it will be x plus 5 squared plus 12. Now let's continue on the next slide to see. This is the general again, and this is the standard. That's the same function, different forms. Now, to find y-intercept easily, you go to the general here. See, let x equal 0. So y will be minus 63. If you bring this graph down, 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 it will be minus 63. Now, to find x-intercept, easier, go there in the standard, you see. Put y 0, and now take this 12 on the other side, divide by minus 3, take the square root of both sides. So it will be minus 7 and minus 3. So where the graph is above the x, from minus 7 to minus 3, open, and that's the graph here. So nice and easy. See the graph for sure, it will be reflected, shifted on the left, shifted up. See, this is the graph. Same idea here. Example 2, I changed the numbers here. Positive A, negative B, positive C. Same question, where the graph is decreasing or increasing, we can ask anything. Just a repetition here. You can practice yourself. So h will be minus b over 2a minus minus 12 over 2 times 2. So a2, b minus 12, c 23. K will be 5, so the vertex will be positive 3 and 5. Write it in standard. No x-intercept. Oh, let's find x-intercept. Put y0 in the standard. We get something squared is equal minus 5. Complex solution, so no x-intercept. Y-intercept will be 23. See, the graph will be opening up, positive, 3 units to the right, 5 units up. The range will be closed from 5 to infinity, where the graph is decreasing from there from minus infinity until 3. That's decreasing. Now, use completing the square method. We can use, see, this is the same as example 2. You can see 2x squared minus 12x plus 23. We can use completing the square also to write the quadratic function in standard form. Instead of using h and k here, you can always use h and k. And also you can use completing the square. Look here, nice method. Completing the square. See, this is a function here. And we know in completing the square, the leading coefficient must be 1. So this must be 1. But since this is a function, do not divide by 2 or any other number in the functions. So what do we do? Instead, take 2 common factor here, only from the x squared and x. Leave 23, 23, 23, 23, 23 until the end. Now inside you complete the square. Take the coefficient of the x, divide by 2, and then square it. So you add and subtract in the brackets. Remember, add and subtract in the brackets. Because we used completing the square in the circle, it was like something equals 0. You can add on the right side and the left side. Here we are completing the square inside the bracket. So the first 3 will be complete or perfect. Minus 9, multiply again 2, that's minus 18 plus 23. This is the standard. You can check example 2. Same numbers. Now, example 4, also let's practice on completing the square. We have a minus 3x squared minus 2x plus 1. The reason I gave this, because we have fractions. I will show you. You can try it yourself if you want, but it will be a fraction. Now, we take here minus 3 as a common factor. See this minus 3 common factor from the first 2 terms only and leave the plus 1 outside. If you take minus 3 from there, because we need this one, the leading coefficient must be 1. Minus 2x, if you take out minus 3, the sign will change. It will be plus 2 over 3. Just to make sure, multiply minus 3 times this. Minus 3 times 2 over 3. Cancel the 3, becomes minus 2. So that's correct here. So if you take 3 common factor, inside here it should be 2 over 3x. Now 2 over 3 divide by 2, multiply by half. It will be 1 over 3. Square it, 1 over 9. So you add 1 over 9, subtract 1 over 9. Now the first 3 is perfect. That will be x, the square root of x squared, the square root of 1 over 9, x plus 1 over 3 squared minus 1 over 9. Then I multiply back minus 3. Remember, there is a minus 3 out. So this becomes minus 3 here. And minus 3 times minus 1 over 9 becomes plus 1/3, plus the 1 from the question. So that will be 4 over 3. So the vertex becomes minus here, 1 over 3, 4 over 3. Let's look here at the properties of the quadratic functions. This is like a summary of the whole lecture. So the vertex, as I mentioned before, h and k minus b over 2a, f of minus b over 2a. The parabola opens upward like this. If a is positive, so this is the leading coefficient, and it has a minimum here. See, the minimum is the k. And the range also will be from k up to infinity. Opens downward if a is less than 0, so the parabola like this, and it has a maximum. The maximum also is k and the range will be minus infinity to k. Then there is an axis of parabola, or sometimes we call it axis of symmetry. This is the line x equals h or minus b over 2a. So this is an imaginary line in the middle. We call it axis of parabola. Now, given the function here, this is like an exam type. 2 square root of 3 minus x bracket 2 minus square root of 3x. Find the axis of parabola. Find the minimum value of the function. So for sure here, by looking, the function is not arranged, so you have to rearrange it. And then always you start with the vertex and the standard form. So you rearrange the function here, just multiply minus 2x, you see here, minus, and then plus square root of 3 x squared. Find a is the coefficient of x squared, and then minus 2 is the b, 2 square root of 3 is the c. Find h, minus b over 2a. Put the numbers there, and you can find it. 1 over square root of 3, rationalize, it will be square root of 3 over 3. Now the axis is this one, x equals this. This is a vertical line. So the axis of parabola is this. Since the formula x equals h, I can show you the formula here. This is the formula. The axis of parabola, or the axis of symmetry, is x equals h. Now to find minimum, remember minimum is the k itself. Remember the minimum is the k. So I have to take h, square root of 3 over 3, and put it in the function in f of x. So it will be 2 square root of 3 minus 2. This is x plus 3. This is x squared. So when you simplify all this, please try to do it yourself. You should get 5 square root of 3 over 3. Easy numbers, addition and LCD. So the minimum is this, 5 square root of 3 over 3. For sure you can graph it. You can find x-intercept, y-intercept. Now the x-intercept in the parabola here, if I ask you how many cases we have in the x-intercept, I think the answer should be 3 cases. So either we have 2 x-intercepts if the discriminant is greater than 0. We have 1 x-intercept if the discriminant is 0. So here we have the graph tangent to the x-axis. Or no x-intercept if the graph is above the x or below the x. So in this case, the discriminant is less than 0. We have seen this in quadratic equations. Now find the number of x-intercept. Only we need the number and the x-intercept. So there are 2 questions here. If there is any of the quadratic function. For sure, this quadratic function is not arranged. X minus 1 squared plus x plus 1, x minus 2. So we have to multiply, add, and subtract until we get the function arranged. So x minus 1 squared, you use the formula here, x squared minus 2x plus 1. And then here you multiply by FOIL method, x squared minus 2x plus x is minus x. Directly, I put here the answer, minus 2. You see, I put the answer directly there. Then you can add 2x squared minus 3x and then minus 1. So this is A and B and C. So the discriminant in this case will be 17. C positive, B squared minus 4AC. So we can say 2x intercept. Now to find them, you can use quadratic formula, or you can change it to standard form and find x-intercept. So this is the graph here. Now let's look at example 7. Find the maximum value of this function. That's a quadratic function, as you can see. So the graph is a parabola. And here we have a is an ugly number, minus 32 over 20 squared. This is all a. B is 1, C is 5. So the parabola opens downwards like this. So there is a maximum. We need to find that maximum. Now, this is arranged already. Let's find h in the vertex. You know the formula, h minus b over 2a minus, see the b here is the 1, minus 1 over 2. All this is the a. You can, if you like, you can simplify the a on the side, or you can put it directly in the formula here. 2 times the a, minus 32 over 20 squared. The answer, 25 over 4. I will leave this for you as a little practice. Make sure you get the answer 25 over 4. Now to find the maximum, we need k, because k is the maximum itself, f of h. h is 25 over 4. So I replace 25 over 4. See, in the function here, 25 over 4 is squared. And x here, 25 over 4. And remember, a minus 32 over 20 squared. 20 squared is 400. Plus 5. See, 5 also from the question. If you simplify all this, another, sorry for this, guys, another little practice in numbers, you will find nice color here, 65 over 8 is the maximum. Please try it. Now, question number 8, find the range in interval notation of this function. Minus 3x squared plus 6x plus 2. We need the range. Now we know this is a quadratic function, which is a parabola. So we have to find the vertex. Also, we can put this question as a final exam multiple choice. A, B, C, D, E. We can say find the range. Nice for final exam. The range will be 1 to infinity, 5 to infinity, minus 5 to infinity, minus infinity to minus 5, minus infinity to 5. Same function, we need the range. Now, this is already arranged. So A is minus 3, B is 6, C is 2. So let's find the range. We need H and K. H minus B over 2A. So minus 6 over 2 times minus 3, which is 1. K will be f of 1. So I put 1 in the function there, we get 5. A less than 0, see, A less than 0, minus 3. So the parabola opens downward, and the range will be from minus infinity until the k here, the k. So the answer is the E. Now I prepared here around 8 old exams questions. The first one is the nice one because we have parts A, B, C, D, E, F, G. Almost comprehensive question. This is a quadratic function, minus x squared, minus 10x, minus 24. Answer all these questions, please, at your free time. Question number 2, 2 parts. 2 parts and 2 questions. Find the number of x-intercept for each. Find the x-intercept if there is any for each. So there are 2 functions and 2 parts for each one. This is a nice question. We need the interval or intervals where the graph of this function is below the x-axis. See, we have f of x minus square root of 2 over 2x squared plus 2x plus square root of 2. That's a quadratic function. Where the graph is below the x. Please try it. Now, where the graph is above the x, find also the range. This is y equals 7 minus x, x plus 6 minus 42. Very similar to question number 3. But question number 3 here, old exam question number 3 is arranged. A, B, C are there. And here, y means f of x. You have to multiply and rearrange it, please, until you get A, B, and C. Question number 5 is an important question. We need to find the equation of the parabola in standard form. I give you the vertex here, 1 and 2, and passing through the point minus 2, 5. Here, find the maximum value of the function. We did one example similar. Please try it. Nice question. Find the maximum value. And this one, if x is equal minus 2, is the axis of parabola of this function. 2f of x is equal x squared plus 2mx minus 12. Find these parts, 1, 2, 3, 4. Write it in standard form where the graph is decreasing, etc., etc. Old exam question number 8. We need to find the equation of the line. This is really good. Passing through the vertex of the parabola here and the center of the circle. So this one combines like 3 lectures. Equation of the line, remember there's an equation of the line with the slope, and this is the vertex of the parabola. We take this point, and there's a center of a circle, we take this point, and then we try to find the equation of the line. Now, as usual, all these are the answers. of questions 1 to 8. Now, just little remark, please, for complete solutions of all these 8 questions, if you want to see them, please, you can go to the video, all the exams questions, quadratic functions, lecture 34. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is lecture 34. I wish I can see you in another video with another topic. Thank you very much.